Today we're going to continue with Chapter 13, and today we're going to talk about some properties of visible light. So, when we describe objects, there's different ways that we can describe objects or materials. Now, an object that is illuminated, the word illuminated means it gives off an illuminated object means that light shines on it, and that's the way that we can see it. So an example like this would be the moon. The moon does not give off its own light. So when we look up at night and we look at the moon, the only reason we see the moon is that light from the sun is shining on the moon, and that's what's causing it to be illuminated. So illuminated objects are objects that light shine on. So again, the moon is an example of an illuminated object. It does not give off its own light. So a point source is just a tiny point of light. So an example like that would be like a flashlight. An extended source, and I'll show you this when I turn this off, an extended source is a light source made up of many point sources. So an example of this is if you've ever looked at a satellite picture, and that's what I'm going to show you later, of let's say the United States at night, what happens is it looks like where there's big cities and like the east coast of Florida are completely lit up. And the reason they look like that is it's actually millions of little teeny lights, but when you're looking from space, and because there's so many of them, it looks like just one solid source of light. So that's what an extended source is, and I'll show you that in a little bit. When I describe materials as being transparent, translucent, and opaque. And these have to do with how visible light passes through them. So an object that is transparent, that means it lets all the light pass through them. So an example of that would be like clear glass, air, water. So you can, if you're looking through clear glass, you can still see images through them. A translucent object lets some of the light pass through it. And opaque blocks the light from passing through it. So it's important for us to understand when we're describing materials that transparent, translucent, and opaque. So again, examples of transparent is like a lens, because those of you who wear glasses or contacts, you're letting all the light pass through and form images, and we're going to learn about images forming through lenses in the next chapter. A cotton handkerchief is translucent in that it's going to let some of the light pass through, and a penny is opaque that it's going to block the light. Now what happens is we have shadows, and shadows block light, and there's different parts and types of shadows. So an umbra is the dark black part of the shadow, and I'm going to do all these demonstrations when we're done with the notes. So this is the part that it blocks all the light. The penumbra is the outer gray part. Now this is extremely important when you're understanding about eclipses. An eclipse is a phenomena that occurs because of the alignment of the sun, the moon, and the earth, and how they are in reference to one another. So we have solar eclipses, and we also have lunar eclipses, and understanding parts of those shadow. Now, in about 10 years, where we live, we're going to have a total solar eclipse. And a total solar eclipse is where, for a few minutes during the day, all the light's going to be blocked out from the sun. And that's something that you kind of see once in, luckily, maybe once in a lifetime. I know when I was, 6, my parents took us up to Nova Scotia back in 1971. And because there was a total solar eclipse there, and so that's going to happen. Now, sometimes we might have there's been times during school where there's been a partial solar eclipse, and I have solar eclipse viewers, and we've gone outside and seen it. It's something really neat to see. So we'll also check the website. I have it on a link on Edline it's called heavens-above.com. It's the best astronomy website, but we can look for our area when we're going to have either a partial solar eclipse or a lunar eclipse and stuff like that. Going back to what we already learned about visible light, we know it's composed of different wavelengths, Roy G. Biv, we already talked about that. We already saw that when it goes through the prism, it's broken up into its different wavelengths. and then the different colors and pigments of light, depending upon to mix other colors. All right, today we're going to talk about polarization, and we're going to do a lab on polarization next week. So polarization, the separation of a beam of light so that the vibrations are in one plane. So we have polarizing filters, and you've probably heard of the word polarization when you refer to sunglasses. Now down here, we're really close to the water, and it's important. What a polarizing filter does is when it blocks out a plane of light, it's actually preventing glare. So if you're near the water and down here, it's actually very important to have polarizing sunglasses. You can also get polarizing filters that you can put on the end of cameras, those of you who are in maybe the photography class. And again, that polarizing filter that you're going to put on the end of the lens of a camera, that's going to block out the glare that's produced from the visible light. And the glare is from the light bouncing off a reflective surface, whether it be water usually or something like that. Light can be polarized by reflection, refraction, and selective absorption. That's going to be a question on our lab next week. And I'm going to demonstrate in a few minutes what I'm talking about with polarization. So anyway, this is the end of the notes, and that's it for today note-wise, and then we're going to do some demonstrations right now.